Good morning, students. Let us continue with the new topic in chemistry, that is electrochemistry and sensors. What is electrochemistry? It is a branch of chemistry that is going to deal with the electrical conductance. That is, we are going to see how the chemical energy is getting converted to electrical energy. We know that the materials are generally classified into three types or kinds as conductors, insulators, and semiconductors. So now when you take conductors, they are the solids like metals which would allow the electric current to pass through them easily and readily. Similarly, there are certain liquids, even they can allow the electricity to pass through them, and they are known as electrolytes. As we have good and bad conductors, we have strong and weak electrolytes. Now, it becomes very important that when you want to conduct electricity, you need basically electrodes, electrolyte, and a electrolytic bath. Hence, the electrodes plays a very important role in the conductance of an electricity. What are generally electrodes? They are nothing but they are metal strips or metal rods with a high potential to lose or gain electrons. That is, the electrodes can lose one or more electrons, and at the same time, even they can gain one or more electrons. On the basis of that, they develop a potential around them, which is known as the reduction potential as well as oxidation potential. So, based on these two, oxidation and reduction potential, they construct a cell, and we know that a cell is an immediate source of electrical energy. Now, when you want to construct a cell, you have to choose the electrodes. One electrode should act as an anode, and one electrode should act as a cathode. It is very important. Now, when you choose the metal which would act as an anode, it must be able to lose one or more electrons. That is, it should be able to undergo oxidation. Similarly, and when you want to choose a metal which acts as a cathode, that must be able to accept two or more electrons. Okay. So based on this condition only, you can construct a cell. Now, the choice of the metals which act as an anode and cathode, and the selection of the metal which would act as an anode and cathode is easily done with the help of a particular series which is known as electrochemical series or EMF series. Just, just by seeing the table, you can have a vague idea on the metals which can act as an anode and which can act as a cathode. Now, what do we mean by electrochemical series, otherwise EMF series? These are the series of number of elements arranged in the increasing order of their standard reduction potential. That is, as you move from top to bottom, the standard reduction potential is getting increased. That is, as you move from top to bottom, the reduction potential increases from negative to positive value. Now, these elements are arranged with respect to hydrogen. Why? The hydrogen is the atom or is an element or is an ion, H plus ion, has zero reduction potential. Okay. So with respect to hydrogen, some of the elements are arranged above and some of the elements are arranged below, usually metals. The metals which are arranged above the hydrogen ion are said to have reduction potential, and the elements which are arranged below the hydrogen are said to have oxidation potential. That is, the elements on the top of the series act as a strong reducing agent, and the elements at the bottom of the series act as a strong oxidizing agent. Okay. Now, what are the uses of these series? The first one is to calculate the standard EMF of a cell. Each cell will be having a particular EMF. EMF is nothing but it is the strength of a cell. For example, if you take a Daniel cell, the EMF of a Daniel cell is 1.1 volt. How do you calculate this EMF? This can be done with the help of a formula. Suppose you have a cell. So the EMF of a cell is given by a formula ER minus EL. What is ER? This is the electrode potential of the right hand side electrode. What is EL? It is electrode potential of the left hand side electrode. Now you have to choose a metal which can act as a left hand side electrode and which can act as a right hand side electrode. Now, which metal will be chosen as a left hand side electrode? That is the elements at the top of the series. In the Daniel cell, you have two electrodes, one is zinc, another one is copper. Now you decide which will act as a left hand side electrode. So left hand side electrode is the anode. Okay. It should undergo oxidation. Otherwise, it must act as a reducing agent. So what do you have on the top of the series? Go back. So where do you have zinc and where do you have copper? You can see that the zinc is at the top, and similarly you have a copper at the bottom. So now you come here. So ER, naturally, the left hand side electrode must be a zinc. Another one is right hand side electrode must be a copper. So 0.31, 0.34 minus of 0.76. That is zinc as a negative reduction potential and copper as a positive reduction. That is plus 0.34 minus of 0.76. Find the total. It is 1.1 volt. Okay. Next application is relative ease of oxidation or reduction. That is, easily you can find which elements will undergo oxidation and which elements will undergo reduction. So I already told you the elements which has the negative reduction potential undergo oxidation. The elements with the positive reduction potential undergo reduction. So you have zinc, lithium at the top. So zinc minus 0.76 volt, lithium minus 3.01 volt. So they have a higher tendency towards oxidation. They can easily undergo oxidation. You have fluorine plus 2.87 volt. You have copper plus 0.34 volt. So they have a positive reduction potential. So they have a higher tendency towards the reduction. They can easily undergo reduction. Okay. Next one. Easily you can decide which will become more anodic and which can become more cathodic. That is, what are the metals, otherwise elements which are noble in nature, and what are the metals, otherwise elements which are highly reactive in nature. That is, when the metals are reactive and they are more prone to corrosion. For example, you take iron. Yeah. So usually the metals which are at the top of the series, which can undergo oxidation, which can act as an anode, and they are more prone to corrosion, they can be easily corroded compared to the elements at the bottom of the table, the series. So generally, they are noble. That's why you have gold, platinum, and silver at the bottom of the series. Next application is hydrogen displacement behavior. You can find out which metal will displace hydrogen from the respective acid. For example, you have two metals, zinc and silver. Now, from the example as shown here, you can find out which will replace or displace hydrogen from H2SO4. That is, zinc plus H2SO4, the reaction continues to form zinc sulfate and hydrogen gas, to liberate hydrogen gas. But in the case of silver, the reaction does not take place. So the result is the elements with the negative reduction potential only can displace hydrogen from acids. They are more reactive. Whereas the elements with the positive reduction potential generally do not react with the acids. Next one. How do they react with respect to the compounds? Suppose when you add the element zinc, metal zinc, to the solution of the metal from the bottom. For example, you choose a metal from the top, zinc. You take a metallic solution from the bottom of the series, copper, solution of copper, that is a copper sulfate. Now, when you add a bit of zinc in copper sulfate, the reaction takes place and the products are zinc sulfate and copper. So, the zinc is affected when it is supposed to get mixed with the copper sulfate. Whereas if you put copper in zinc sulfate, no reaction takes place. Thus, the metal which is at the top of the series can replace the metal from its metallic solution. This is the result. We can also predict the spontaneity, otherwise feasibility of the reaction. How much the reaction is feasible, whether it's possible or not, whether the reaction takes place on its own or not. That can be found with the help of EMF series. For that, you have to get the value of delta G, that is the free energy change, should be negative. Okay. So, any chemical reaction is possible when its free energy change is negative and the EMF value is positive, because E is equal to minus delta G. Okay. So the EMF should be positive and the free energy change should be negative. Then the reaction is spontaneous and it's feasible. If the E naught, the EMF of the cell is negative, then the reaction is not feasible and it is not spontaneous. Last application is you can find out the equilibrium constant of the reaction using the EMF series, that is with the help of a particular expression minus delta G is equal to ENF. Already told you delta G is equal to E is equal to minus delta G. I already told you. And so delta G, the decrease in free energy, that means the reaction is feasible. That is equal to NFE. N is the number of electrons which has been lost or gained. F is the Faraday current, and E is the electrode potential. Okay, otherwise EMF of the cell also. Clear? So that is indirectly again related to the equilibrium constant K. So delta G is equal to minus NFE naught, and that is equal to 2.303 RT log K. R is the universal gas constant and T is the temperature. So using this relation, you can find out the equilibrium constant of the reaction. Clear? So far, we have seen the different applications of EMF series or electrochemical series, which is very important concept from exam point of view. I hope all of you have understood. Let us see in the next class. Thank you.